Yeah,
Yeah,
do you want to do a quick introduction or should I
mhm.
just go ahead?
Let's go ahead, Trevor. Uh,
Okay. So, as everybody on the call should probably know, the first step of having trusted test methods in the laboratory is to understand how well those test methods are can be repeated. Anybody can go to a laboratory, run a series of tests, and under different conditions get different results. But how do we faithfully depend upon that information without knowing either the pedigree of the test or the pedigree of the laboratory? So here we are talking about precision in corrosion inhibitor selection as the first step in testing inhibitors for oil and gas applications. So go ahead and advance the slide. What we're trying to do with this webinar series is gain consensus of thought in the need for establishing uh, standard test methods. And we want to really underscore the importance of this published precision, which the definition of precision now, if you're old like me and Joe on the call, you might have used to think, been raised to think that precision was the number of decimal places in a laboratory evaluation. But ASTM and ISO have got behind their definition of precision now, which is really repeatability and reproducibility of a test method. So we'll be talking a little bit in this series about how to develop these standard test methods and the work that we've done so far to get down this path. And we will be underscoring the importance of this collaboration to develop consensus-driven standard test methods that we can all trust. And we'll talk about the importance of these test methods on industry best practices. A lot of companies in the oil and gas industry, from wellhead to where we sell the product, rely on these test methods. And so we can't understate the importance of this. So yes, the phase one and phase two of the JIP were basically crowdsourcing what people are doing. Phase two was to synthesize the different ways people were adapting their test methods. And the phase three now is working out the precision statement on some of these standard test methods that we have come to rely upon. And you can skip to the next slide here. Is this the fourth slide or are we there?
this is yeah.
Okay, okay. This is an identical slide to the first slide. This is our fourth webinar. And we'll be talking about the role of screening and selection in these inhibitor evaluations. I will touch based on the next slide or two, uh, just to underscore the differences in where the industry is at for corrosion inhibitors compared to some of the other areas where we use test methods in corrosion control. And we're going to highlight just the difference, which, you know, uh, 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 what's it's highlighted in red there on the slide. But when we talk about materials, we've got established test methods that are they're well established. The pedigree is high. Laboratory repeatability is we've got high confidence, and some of these test methods have now been embedded into the actual regulations governing how people use materials. The case that we have here is MR0175, which is related to sulfide stress cracking and hydrogen damage. So this is a well-established area, well-established test methods, and we've got quantitative criteria for acceptance of materials. Similarly, in coatings, we've got the embedded requirements and regulations to use different test methods to evaluate your materials. There are training programs available and certifications aplenty. And there's, again, quantitative criteria for evaluating the suitability of a material for protective coating. Cathodic protection, again, we see the same thing. The requirements are embedded into our regulations quite vigorously. We have standard test methods that have been published that we've all come to trust. There are certification programs. And again, we've got quantitative criteria for when that is effective and when it's not. In contrast, we've got this 80-year-old business of corrosion inhibitors, where the regulations only touch on stuff you need to do if you use corrosion inhibitors. They don't tell you when you should use corrosion inhibitors. So it's not embedded in the regulations. We have only one test method which can be considered an ASTM level course, that's G202. This is because this test method was investigated. Consensus found it was a good test, and it was repeatable and reproducible. There is an ASTM training course on inhibitors, but the criteria for evaluating corrosion inhibitors is still a qualitative consideration left up to individual operators. This is what we're hoping to address. Next slide, please. So this just underscores again the development of these. Cathodic protection goes back a long ways. We've got the Shankara calls it iconic publication RP0169. Coatings, a lot of work done from 40s, 1970s, and there's 13 ASTM standards. For some reason, this one is the one that has the greatest number of standards that we use. Materials, the MR0175 had its origins back in the 50s when sulfide stress cracking was first being discovered. And so it's been around for a long time. And yet corrosion inhibitors, which if you look back on the historical documents, you'll find that corrosion inhibitors were being used back in the 1940s. And yet the first actual sort of published standard was in 2009 when ASTM G202 was published. So we're hoping to improve that. I think I'm going to go to the next slide here, Shankara, and I'll hand it off to you to continue because it's going to get technical as we go.
Thank you, Trevor. Actually, the next slide will be presented by Joe Pikas. Joe, the floor is yours. And
unmute. Okay. Thank you, Sankara. And I just want to give a brief history on the development. As we all know, NACE started in 1943. I know it's hard to believe, but it was just a group of about a dozen engineers, and it was the National Association of Corrosion Engineers, even though we had one foreigner that was from Canada. Only kidding. We were an international group from the beginning, but they call it the National Association of Corrosion Engineers. And the big thing was to primarily address corrosion control with external corrosion to criteria and so on, CP and coatings. However, there was a hiatus that had occurred from 43 almost up to 1969. That's when they came out with RPO 169. And what happened in that time period? Why wasn't there any recommended practices, as they call them at that time? Now they're SPs. Well, we had World War II. That was number one. And things, the 50s were kind of slow. And then the 60s come along and still nothing, we got a lot of things occurred in the 60s, but there was no change until the U.S. Department of Transportation decided that they were going to put a gas rule together in 19. They were going to put it out in 1969 to notice the proposed rulemaking. 68, 69. And they came to NACE for a specific reason. And they asked them, hey guys, can we get something on external corrosion? Internal wasn't even part of it. And my old boss, Sal Balassi, actually, I got into corrosion in 1969, and that's another story. I don't want to spend time on, but it's kind of funny. But I'll leave that one go. They fought me on that. They said you weren't in 1969, and I had to prove it to them that I was. That was funny. But anyway, I'll tell that story another time. But my old boss, Sal J. Balassi, actually, he was on that committee, and he actually became an editor to NACE after he retired. So because he was involved in corrosion control from the beginning, and also he was a vice president of engineering for Transco, which is now Williams Transco gas pipeline. So the history behind it. But the problem was the regulators took the 5 criteria that were in there. At that time, there were 5, and they adopted them under Appendix D of the U.S. DOT 192, which is the gas regulations. And unfortunately, they never gave credit to NACE, and they didn't acknowledge it, even the standards, which was a big downfall. And there was some reasons behind it. I'm not going to get into the reasons. They were good, bad, and ugly, but they had specific reasons. They didn't feel they were really up to par, like ASTM and ASME and API. So they kind of left them out in a cold. But of course, we know better. Since that first recommended practice came out, which is it's an SP now. When we've come a long way, and I think some of the standards that we have put together, the MR, R, and so on and so forth, and some of the coding standards have really done a lot. And now, as we hear, we need to do something on the inhibitors. So just to let you know, I've been in NACE from 69. I think now that Bob Gummow, I understand, retired, I may be the oldest one in NACE. I'm 82, by the way. So, but I heard there's one other guy that's 85 years old. He's here in the States, I believe. So thanks, everybody.
Thank you, Joe. And I'm sorry again, I didn't introduce Joe Pikas or Trevor, please. But I think everybody knows them in the industry. They have been the stalwarts of our industry for a long period of time. Really, thank you, Joe and Trevor, for the introduction. Couple of points. Again, Joe, you said you are 82, and I've been seeing you for the last 30 years. You still look the same person as I saw you 30 years ago.
However, there's reasons for that.
Yeah.
I'll tell you my routine every morning, 4:00 in the morning, workout. I eat the right things, and I still get in trouble. So
okay.
Anyway,
okay. Thank you.
This is me live, so in case you guys
thank you.
Don't remember me. Okay.
Yeah. Thanks, Joe. One other side note, Joe said he's 82 and there is a person who is 85. Actually, to my knowledge, the oldest NACE member or ASTM member is Shaldin Dean. He's also an ASTM member. Shaldin, as I know, is 92 and is still very active. So, but the point of the discussion that Joe brought to us is that If we do not do any action, regulators will prompt us, as it happened in way back in 1960s. That is the premises with which we are moving with this webinar series, as well as the joint industry project that Trevor is leading. So let us switch the gears, so to say. Let us stop for a minute about corrosion inhibitor evaluation. Let's talk about driving the vehicle. In my opinion, there are 6 steps in driving the vehicle. Step 1, obviously, you have to learn to drive, and we have got training centers. Step 2, obviously, you have to apply the license by undergoing the road test that is provided by regulators. And then as we drive our vehicle, we come across some speed limits, 45 kilometers per hour, 45 miles per hour, and so on. How do they come up? That comes up from user experience. Of course, regulators impose it, but it comes from user experience. If the road is curvy and if it has led to some kind of incidents, then the speed limit is imposed, again, based on user experience. And then you will also have another thing. You got a speed limit, and then you have a monitor which says, what is your speed limit? Normally, honestly, I never met the speed limit. If it is 45, I always try to drive at 50 or maybe 55. But when the monitor shows you are at 53, I try to slow down. So that is another kind of warning, pre-warning, developed based on user experience. And then we have got speed cameras all across the different parts of the cities and the countries. I would like to relate one story. A few years ago, we bought a new car, and the salesperson told, hey, I can give you 10% off if you allow me to track all your driving habits. And I know I'm a bad driver and my wife can vouch on it, but I don't want somebody to tell me how bad I am. But the point is that now people can track how we are driving, and in a way that is correlated with insurance companies. For example, when the salesperson told me there'll be a 10% reduction in the cost of my vehicle, and also if I allowed him to track my driving, they will also speak to my insurance companies and reduce the price further, the cost of insurance further. So speed cameras are there everywhere. If you do not follow any of the rules, then you will be serviced by police officers, which we do not want. Let's translate this one into our inhibited testing. This doesn't happen, but the premises of this webinar series and the JIP is to make it happen. Right now, as Trevor pointed out, if you want to test an inhibitor, ideally, you should start with ASTM codes. But in most of the cases, we self-learn. There is no agency which gives a certificate or license to test. Most of the individual industry laboratories do the training and allow the technicians to do particular tests. What we are going to focus in this webinar, as well as in the JIP, is to establish the user experience by establishing boundaries of laboratory methodologies. If I do the test under this condition, what kind of results I get? That is a repeatability. That is the main focus of the Joint Industry Project Phase 3. Again, we'll talk more about the difference between screening test and selection test. Similar to the speed warning, we also can establish reproducibility through either ASTM or AMP or the joint standard. So that establishes the boundaries of laboratory methodologies operations based on multiple user experience. Again, focusing on screening test. I will talk more about the insurance experience in the next slide, but some or most of the laboratory operations are also tied in with insurance. Every operations requires an insurance, professional liability insurance. So sometimes in other industries and other corrosion control strategies, they are tied into the insurance companies. So our idea is that if we can take care of step 3 and perhaps step 4, then we will be ahead of the regulators. Unlike the SP0169 or RP0169, instead of regulators imposing things on us, we can lead the change. So that is the premises of this webinar series as well as the joint industry project. So let me share with you 3 experience of insurance. When I start driving, before I obtained the license, I had to go for a test for training. Only then the auto insurance decreased my insurance premium by 50%. So my performance in driving is tied into 2 things. One, my driving license as well as my ability to drive. So all of our performance are related to some kind of insurance. Let me also share with you some of my own company's insurance policy. Every year, I do, or for the matter, every company does 2 things. One, pay the dues to our government agency to establish the insurance policy. This is one of the dreadful thing for me personally. Every year, I have to renew my insurance and they will ask me all kinds of questions. What is your professional experience? They don't care about the previous experience. I have to restate what is my current expertise, whether I'm capable of doing it, what kind of training I'm undergoing to ensure that my expertise stays in the level it was last year. Then they'll ask me, who is the supply chain? Are you giving any project outside Canada? Who is the supply chain? And then who are your employees? Whether it's temporary or permanent, what are their experiences and expertise? So all these parameters are considered every year in establishing my insurance level, the level of premium I have to pay. So intuitively, whether we like it or not, even corrosion independent evaluation is tied into some kind of insurance. I would like to share one experience. This is not my experience. This is one of the experience shared by one subject matter expert. Apparently, he was hired by company A, producer, as a consultant to advise on the optimization of operations and to execute management of changes. This particular person was offshore for almost 2 years and he couldn't make any change. He was so frustrated, he resigned the job and he was coming back to Canada. Again, I heard it from the person. I think it's a real story. So as he was leaving the other country, he happened to meet with an insurance agency accidentally in a bar. And the agent told, what are you doing? And he said, I'm leaving. And then said, that's a company for which we are insuring. Now let me hire you as my consultant to ensure that the company A is performing this task they said they are doing. And let us tie in the insurance coverage to the management of changes. When this subject matter expert went back to the company, he was well respected. Whatever he said was followed. So the management of change happened. So let us not forget that sometimes external forces have higher influence on us than we think. So with that background, let us see what is the difference between screening test and selection test. We are going to standardize or develop standard test methods on screening tests, which is within the scope of phase 3. Screening tests are normally carried out for a shorter duration, typically less than 24 hours, under standard conditions. That is our focus, establishing standard conditions. These screening tests are used or should be used by chemical suppliers or owners, as well as operators, as an economic means of developing a short list of chemicals from several chemical suppliers. So instead of starting from the scratch, the owner operators can pick from a short list of chemicals. In some parts of the world, screening tests are also being used by owner operators to ensure quality of chemicals at various frequencies during routine operation. So every now and then, the owner operator pick the chemical that was supplied and do the testing to ensure that that meets the quality, for which also screening tests are used. The last bullet is not common in North America, but it is a very common practice in other parts of the world. They use screening tests, the owner operators, to select chemical suppliers. Once the chemical suppliers are selected, they will have the free wheel to do their own selection test and apply the corrosion inhibitors. So screening tests play a vital role in inhibitor evaluation. Again, screening test does not provide all the information. It's a starting point. The selection test, which is not within the scope of JIP phase 3, but it is normally carried out for a longer duration, simulating as close as possible the real field operating conditions for which the inhibitor is being considered. Selection tests are normally for longer duration, are usually done by owner operators to select a chemical or a slew of chemicals for field testing. So definitely there are two time frames. One for screening test, shorter duration, selection test for a longer duration. This kind of separation intuitively happens in other corrosion control methodology selection. Let me give an example. If you asked a supplier to supply pipeline coatings, these are all well established, published by AMP, NACE, and ASTM, as well as other standards. If you want to supply a coating for us, these are the preliminary screening tests you should have, and that should be included in your product specification. Well published so that you can search the internet and find out what are the companies that can supply the coatings based on short-term screening tests. And then the owners, they also prescribe their own criteria. If you are going to give the coatings to us, these are the tests you should do it for us, for our specific case. Again, you see that one selection test for the coatings is done for 24 hours. Sometimes screening test is done for 24 hours. Selection test may happen for over 200 hours. So there is specific difference between screening test and selection test. Both have a vital role to play. With that background, let me give a clear one example as to how we can benefit by using both screening tests as well as selection tests. For a discussion, let's assume that we have done a selection test using ASTM 202. These are all the conditions. If you follow ASTM 202, as per the published repeatability and reproducibility, one should get a general corrosion rate of 23 plus or minus 2. So first you tick. Yes, this chemical supplier is able to do the test and able to produce the corrosion rate as per the ASTM standard. The first box is ticked. And then you can say, the owner can say, hey, you provide the chemicals, only chemicals that has more than 90% efficiency under the standard conditions. the second box is ticked. So that way, we can pre-select from the chemical vendors few products based on repeatability and reproducibility. That is the beauty of screening test. Now if we go to selection test, obviously the field conditions will be severe. So we have to do selection test. Let us assume that this particular operating conditions are severe, and then this company has given a contract to a third-party laboratory to do the test. The first question is, if they produce a corrosion rate of 20 mils per year, which is less than the standard corrosion rate, then you should question them. Hey, why there is a difference? If they produce similar corrosion rate range, we can accept it or we can question them. But if they produce a higher corrosion rate, obviously we can accept it because the field conditions are severe. The corrosion rate should be severe. The third box is ticked. And then you can ask them, what is the corrosion rate? If under the severe conditions, the corrosion efficiency is higher than standard conditions, we should question them. How can it be possible? Maybe that's a chemical reaction, so that technical questions can happen. But if you have a corrosion inhibitor efficiency, which is similar to the standard conditions, that box is also ticked. So we are doing the same thing what we have been doing, but we are tying everything to the precision statement. Sometimes people also use localized pitting corrosion. Normally, localized pitting corrosion is not evaluated in the screening test because of shorter duration of operation. But we can also qualify the inhibitor if you do the selection test based on its efficiency on localized pitting corrosion. So the bottom line is that the precision statement will help us a level playing ground as a good starting point to evaluate corrosion inhibitors, and that results can also be used to tie in both screening test as well as selection test. So establishing precision of the screening test will help us to establish a common platform, a level playing field for initiating corrosion inhibitor selection. Definitely, it serves as a beginning, not the end of evaluation. It helps to evaluate, it facilitates evaluating comparison of various chemicals from multiple vendors. So if we are providing a level playing, broad, fair assessment. Screening tests also generate baseline data to support performance evaluation in subsequent selection tests, so that we can compare the inhibitor performance in the screening test as well as selection test. If you are entering new to the market, I believe one of the new chemical suppliers are in the webinar today. So how do they enter it? At this stage, it's difficult or rather challenging. But if you have a screening test with known precision, it provides valuable information to the new chemical suppliers so that enable them to demonstrate that their chemical is also good. It helps them to demonstrate and promote their own products, especially for the new chemical suppliers. Screening test also delivers robust, defensible data for owner-operators, strengthening their leverage in insurance negotiations. Here we do all the 6 checkpoints, and hence our inhibitor program is robust. Thus, screening test not only provides technical advantage, but also financial and regulatory advantages. That is the kind of focus of our webinar. I'll also quickly go through the phase 3 of the joint industry project before we open the floor for discussion. Again, thanks to our sponsors, we are in a good shape, and we have already started the JAP phase 3 on December 2nd. In addition, fortunately, we also obtain some funding to hire partial funding to hire students. Again, leveraging some of the beneficial financial benefits. This slide already Trevor pointed out. We are in phase 3. In phase 3, we are going to develop standard test methods for at least 8 laboratory methodologies that have been identified in phase 1 and 2. And the 8 methodologies are listed here. In webinar 2, I talked about 1 liter rotating cage. In webinar 3, I talked about rotating cylinder electrode. In this webinar, let's briefly talk about why this static and bubble test standardization is important. Even though this is one of the very common tests we all do in our laboratory. Again, let us go back to the background. In our oil and gas industry, we call static test as bubble test or kettle test. Our static, bubble, and kettle test are one and the same. Different names, same test. In the static test, we don't simulate flow, but we bubble gas through the solution, normally carbon dioxide or hydrogen sulfide. We place the apparatus on a heater, kettle, and hence it is also called kettle test. Even though this is a very small, very simple test, there are so many parameters that needs to be controlled during the test. If you don't control, it will show variations. For example, the number of bubbles per second will affect the solution saturation. 2 bubbles per second is norm, but that can affect if you don't control the bubble flow, the flow of bubble. Bubble size also is important. The diameter of the tube through which the bubble goes through will affect the saturation. Some people use aeration if they are going to do the testing under aerated condition. Some people use magnetic stirrer. They all affect the corrosion rate and hence the inhibitor performance. Most of the laboratories, they use either Moore's laws or electrochemical techniques to determine corrosion rate, of which the electrochemical techniques, LPR, is the most popular. Very simple test. Every lab does it. Let's talk about some background. Just before the webinar, we were just talking to Everett Brosha from AMP. NACE did have a technical report 1D196 on laboratory test for evaluating oil field corrosion inhibitors. This was published in 1996, but unfortunately it was withdrawn. While developing the standard technical report, they also did some round robin in 1990s. They did round robin using 2 methodologies, one wheel test, another they call it as LPR, which is basically the bubble test. So they couldn't compare the corrosion rate, but they were able to compare the inhibitor performance of 3 chemicals, A, B, and C. Bubble test actually gave a relatively consistent ranking of the 3 inhibitors. This was done specifically for the oil and gas industry corrosion inhibitor evaluation. Independent of this activity, ASTM in 1970s coordinated another bubble test, which they call it as static test, basically to evaluate linear polarization resistant measurements. This activity was led by Dr. Florian Mansfield, and there is a paper also at AMP 1976. Again, bubble test, static test, they used 2 materials, one stainless steel, one carbon steel. The one on stainless steel met the ASTM precision statement and it made it to the ASTM G59. The one on carbon steel had lots of variations and that it did not meet the requirements of ASTM, and hence it did not get included into ASTM G59. The last bit of background to bubble test. ASTM and NACE had a joint agreement for the last 15 years or so. And now they are in a negotiation almost, I think they are going to sign before the end of this year. There'll be a joint ASTM AMP standards. In fact, there are two standards already, two joint ASTM AMP standards. One of them is TMO, NACE TMO 169 and ASTM G31, which is nothing but bubble test. And the title is Laboratory Immersion Corrosion Testing of Metals. Metals plural. Here, they consider all metals like carbon, steel, stainless steel, copper, and all. If you look at the ASTM language, this standard is a guide. If you look at the AMP or NACE regulation, it's a standard test method. As a consequence, this standard does not fall under either ASTM or AMP classic classifications. That is the background. So with that, what are we going to do in our JAP? We are going to use the same rotating cylinder electrode apparatus, but we are going to conduct the test under static conditions. Our primary role is to establish the precision based on repeatability of the bubble test. Obviously, our focus will be on carbon steel and LPR measurements. This one series of tests will help us to achieve three things. One, obviously, first to demonstrate the repeatability of the bubble test, and hence it could become a standard test method for carbon steel. Two, it can also explain what are the variations caused by LPR measurements when compared to mass loss measurements. Three, it can also explain what are the variations caused by rotation in the rotating cylinder electrode. So three birds in one stone. And if you achieve that one, hopefully both ASTM and AMP will agree to develop a standard, joint standard on the bubble test. That will kind of, in my opinion, will have a huge impact in all our industry. Not only inhibitor evaluation, but also other evaluations. To sum up, in phase 3, we will develop step-by-step procedure to carry out tests in all 8 methodologies that will be standardized in the phase 3. We will provide blueprints for all the 3 methodologies, all the 8 methodologies that will be standardized. This will enable sponsors to manufacture their own apparatus. Solution composition preparation is very, very important. So we will establish standard solutions as well as procedures to prepare them. Probably we'll develop a standard on that one. Obviously, the primary objective is to establish precision based on repeatability for all the 8 methodologies. And we'll submit these results to either ASTM or AMP to develop standard test methods based on repeatability. Our JAP starts there by producing repeatability. Reproducibility, we believe that ASTM or AMP will coordinate. In ASTM, they have a 5-year window to develop reproducibility. Again, repeatability, one laboratory, reproducibility, multiple laboratories. We hope to continue collaborating with ASTM to develop reproducibility after the JAP is completed. Quickly, the sponsorship for the current sponsors is all well established 20K. I was asked to explain the last 3. If you want to join the JAP at this stage for all 3 phases, it is $50K US. If you want to join only for phase 3, it's only $25K US. We also have one different category for third-party laboratories. They need to pay only $25K, but they will get access to the phase 1 and phase 2 reports. Category 3 of sponsors will not get the phase 1 and phase 2 reports, but third-party laboratories who can help us to produce reproducibility statement will have access to the phase 1 and 2. With that, let me stop the recording and then